All right, let's take some look at some factoring problems. So in the first problem, we have 6x plus 12x squared. Now, when something tells you to factor, it means to take out whatever is in common. So in this problem, when we look at the coefficients, which are 6 and 12, what is the greatest common factor that they both have? In other words, what's the biggest number that goes into both of them? And the answer is 6. So I'm going to go ahead and take out a 6. I'm going to write my 6 down here. Now the next thing that they have in common are these x's. Well, how many of them do they have in common? Well, they have 1 in common. So I'm going to take one of them out, like so. Now, we're going to go ahead and set up our binomial, such as this. So what would I have to multiply this by to get the first term over here? So 6x times what gives me 6x? Well, that's just 1. So I'm going to write a 1 in here. Now the sign in here is positive, so I'm going to write down a positive sign. Alright, so now let's do the same exact thing. So 6x times what gives me 12x squared? Well, I know in order to get the 12, I'd have to multiply 6 by 2. So I'm going to write my 2 in here. And then in order to get an x squared from an x, I'd have to multiply that by another x. So this is my answer. Okay, so what if we're factoring a trinomial, a 3-termed polynomial? Well, this is where we have to set up our 2 sets of parentheses. So I'm going to get one set going here and one set going here. Now, the nice thing about this problem is that the coefficient of our leading term is just a 1, which makes this factoring process really nice. Because what do you have to multiply an x by to get x squared? And the answer is x. So that makes that means I get to put an x in each of these first positions. Because when I FOIL later on to check my answer, this is going to be the first term part, the f part. Okay, so now the next part of this is I have to find factors of my last term here, which are 14, that somehow give me a sum or a difference of this middle term, which is the 5. Okay? So let's go ahead and just first of all list out our factors of 14. I know that there's 1 times 14, and 2 times 7, and I think that's it. So if we look at the first pair here, is there anything I could do here to these two terms, add or subtract them, to get a 5? So 14 minus 1, well, that's 13, that's not 5, that's not going to work. How about 1 plus 14? Well, that's 15, that still doesn't work, so this is not going to be my solution. So let's think of the other one, 2 times 7. Oh, that'll work, because 5 minus 2 is 5. Or I'm sorry, 7 minus 2 is 5. But if you look up here, this 5 is negative. So what would we have to do to both of these numbers to make them act that way? And the answer is this. This 2 here would have to be a positive, and the 7 would have to be negative. So that when I do 2 minus 7, that gives me a negative 5. So the part about filling in the rest of this answer, in other words, whatever goes here and here, is whatever we decided that 2 and that 7 should be. So the 2 is positive, so that means one of these gets a positive 2, and the other one is a negative 7, which means the other one gets a negative 7. And let's FOIL this and double check our answers. So the firsts, that means x times x. That gives me x squared. The outer parts, that means the parts that are on the very outside that almost touch the parentheses. So that would be x times negative 7, which would be negative 7x. Now the inside, the two terms that are the closest to this inside part here, which would be positive 2 and x. Well, 2 times x is positive 2x. And then the last part means, what are the last terms of each of these individual binomials? Well, that would be the positive 2 and the negative 7. And what do I get when I multiply those together? It gives me negative 14. So the only two terms here that are common are these. These are my like terms. and we're going to add them together to simplify our answer. So negative 7 plus 2 is negative 5, and then minus 14, and that is indeed what we started with. And that concludes this tutorial.